Game activity and blood lactate in men's elite water polo players. School of Sport and Exercise Science, Faculty of Medicine and Surgery, University of Roma Ter Vergata, Rome, Italy. Don Gnocchi Foundation, Rome, Italy, and Department of Human Physiology, University of Siena, Italy. Introduction. Water polo is a demanding exercise mode that heavily taxes the aerobic and anaerobic pathways. Despite its popularity, only few studies addressing the physiological demands of male elite water polo players. Furthermore, these research studies involve players observed during friendly matches and using former players' rules, i.e., rules laid down before 2006. Recently, i.e., after 2006, the International Water Polo Governing Body, Federation International National Association, FINA, FINA, introduced a number of rule changes aiming to affect game tempo. Consequently, water polo game demands may have been changed accordingly. However, to the best of our knowledge, no research was carried out addressing the coverage rate and physiological demands of highly competitive water polo matches after FINA rules changed. Therefore, the first aim of this study was to examine the coverage rate and game demands of male elite water polo players during highly competitive games. The second aim was to examine the possible role differences in game demands in water polo players. As the working hypothesis, we assume the existence of an increase in game demands as a consequence of FINA's new rule. Methods. Experimental approach to the problem. Since 2006, FINA introduced a number of rule changes that mainly consisted of in shortening the playing time allowed to players to shoot at goal from 35 to 30 seconds, and in extending the quarters by 1 minute, i.e., 4 periods of 8 minutes, each with 2 minutes rest in between. Consequently, the imposed changes over match tempo may have altered game demands, resulting higher than we previously reported. In the attempt to examine game coverage rates and physiological demands, a descriptive design was adopted. In this study, match coverage rates and physiological demands were assessed using time motion analysis and blood lactate concentration during 7 official, highly competitive matches, FINA International Tournament. Although useful to estimate aerobic game involvement, heart rate monitoring was not possible in this naturalistic study because players are not allowed to wear heart rate monitors during international FINA matches. Subjects. Participants of this study were 77 outfield international level men's water polo player, ages 25.9 plus or minus 4.5 years, height 188.4 plus or minus 4.5 centimeters, body mass 92.6 plus or minus 10.9 kilograms. The study was conducted according to the Declaration of Helsinki, and the protocol was fully approved by the Institutional Research Board of the Italian Swimming Federation, FIN. For use of human subjects before the commencement of the assessments, written informed consent was obtained from all players before the commencement of the study. All the players were fully accustomed with procedures used this research and were told that they could withdraw from the study at any time without penalty. Players were all members of the Italian senior water polo. Competitions took place during the competitive water polo season, and all players started in their first division teams, i.e., center forward, 15, field players, 33, center defenders, 29. At the time of the investigation, players performed 2 training sessions a day, with a competition taking place during the week or during the week. Training sessions mainly consisted of technical tactical drills, swimming conditioning, and strength training, 60 to 120 minutes per session. Procedures. Each match was monitored using a computerized semi-automatic video match analysis image recognition system. Win Trainer, We Sport, Chiavari, Genova, Italy. This method uses 2 cameras positioned at roof level around the swimming pool perimeter to record the positioning data of each player every 1/4 of a second during a match. The data captured are then systematically analyzed using proprietary software to provide comprehensive data on each individual, including how much distance each player covered and at what speeds they covered it. To account for match substitutions, 2 further video cameras were used and pointed to the team's benches. Only one team was examined per match. Players' swimming speeds were categorized according to Hollander et al. Specifically, the swimming speeds were grouped into 4 arbitrary zones. Speed is less than 0.8 meters per second, B, speed greater than 0.8 meters, and less than 1.4 meters per second. Speed over 1.4 and less than 1.8. Speed over or less or equal to 1.8 meters a second. The validity and reliability of the match analysis system were assessed before the commencement of the study, having players, 16 swimmers, known distances at various speeds and directions. Players had to swim over a 23.86 meter triangular route with one 90-degree angle previously measured with a standard metal tape. Stanley, New Britain, Connecticut, USA. They were asked to swim along the triangle perimeter at a speed corresponding to 50, 70, and 100% of their previously measured maximum speed. Swimmers' times were assessed and hand stopwatches, Casio, Tokyo, Japan, by experienced coaches. Players, i.e. 16, underwent 3 tests at 7 days intervals. Blood lactate concentrations was assessed from earlobe blood samples randomly taken from players during game substitutions, stoppages, quarters ends, using an amperometric system. Super GL Diasis, Holzenheim, Germany. Blood samples were immediately stored in heparinized test tubes and analyzed within 5 hours. All matches were played under similar environmental conditions. Air temperature 24 plus or minus 2 degrees, 50 plus or minus 10% relative humidity. Statistical analysis. Results are presented as mean plus or minus SD. Data sets were checked for normality using a Shapiro-Wilks normality test, and visual inspection relationships between variables were assessed using Pearson's product moment correlation. Comparisons between means were performed with analysis of variance designed with post hoc Bonferroni tests were necessary. Reliability in the match analysis system was assessed and measured. Agreement between actual distance and speeds versus video analysis data according to Hopkins using intra-class correlation (ICC) and coefficients of variation. Significance was set at 5%, p less than or equal to 0.05. Results. The ICC and CV of the time analysis system ranged from 0.89 and 0.92 and 0.8 and 1.6% for distances and speed respectively. No significant differences were found between speeds assessed via time motion analysis and stopwatch timing, p is greater than 0.05. During the game, players covered 1,613 plus or minus 150 meters, n equals 68. This corresponds to a mean coverage rate, i.e. swim distance, versus time played ratio of 54.1 plus or minus 5.8 meters per minute, 68, and players covered 520 plus or minus 68.3, 369 plus or minus 42.2, 297 plus or minus 55.7, and 426.2 plus or minus 139.4 meters in speed zones 1 through 4 respectively. This corresponded to 32.9, 23.5, 18.6, and 25% of the total distances covered by players during the match respectively. Total match coverage, distance swum in selected speed categories are given in Table 1 according to players' roles. Across quarters, players covered 412.5 plus or minus 86.7, 399.8 plus or minus 38.1, 404 plus or minus 19.4, and 419.7 plus or minus 55.6 meters during the first, second, third, and fourth quarters respectively. P is greater than 0.05. During the last quarter, players experienced a significant decrement in coverage rates. See Table 2. During this study, a total of 110 blood lactate concentration measurements were performed. Mean blood lactate concentrations was 7.7 plus or minus 1.0 millimoles per liter, range 2.2 minus 14.3. During the first, second, third, and fourth quarters, blood lactate concentrations were 7.7 plus or minus 1.2, 7.8 plus or minus 0.6, 7.5 plus or minus 0.9, and 7.2 plus or minus 1.6 millimoles per liter, respectively. P is greater than 0.05. Mean match blood lactate concentrations for center forwards, center defenders, and field players were 11.2 plus or minus 1.0, 3 through 14.3, 6.7 plus or minus 0.9, 1.4 through 8, and 5.3 plus or minus 0.9 millimoles per liter, 2.2 through 11.9, respectively. Blood lactate concentrations for center forwards was significantly higher than for center defenders and field players. P is less than 0.01. Discussion. This is the first study that addressed coverage rates and blood lactate accumulation in elite men's water polo players during highly competitive games after the introduction of new rules. The main findings of this study was the role-dependent differences in coverage rate and blood lactate concentrations in elite water polo players. The results of this study showed that during highly competitive matches, elite water polo players may swim as much as 1,612.5 plus or minus 150 meters. This should be thought of as a considerable distance because none of the study players was employed for the whole match time. A better picture of game coverage rate may be provided by the distance swum per minute of play. Using this notation, players covered 54.10 plus or minus 5.8 meters per minute during the match, with no differences across players' roles in the selected swimming speed categories. Players covered as much as 426.2 plus or minus 139.4 meters in the faster speed zone, i.e. speeds above or equal to 1.8 meters per second, or the 25% of the total distances. Considering speed greater than 1.4 meters per second as high-intensity swimming, players were able to cover 44% of the total distances during their game play. Previous research has found lower match coverage in players of a similar competitive level, but observed during training matches. Indeed, Sardea et al. And Rudick et al. Reported a match coverage of 1,000 and 790 meters, respectively, these distances being remarkably lower than the total coverage found in this study, i.e. 1,613 plus or minus 150 meters, suggesting that changes in rules may have affected match intensity in elite water polo. However, dissimilarity in match analysis systems, i.e. trigonometry versus image recognition, and game competitive level, i.e. friendly games, may have caused measurement variations. Furthermore, in the Sardea et al. And Rudick et al. Studies, no information was provided as per the validity and reliability of the trigonometry match analysis system used for water polo. In this study, for the first time, we used a semi-automatic image recognition system with water polo, differently from the soccer studies available in the international literature that made extensive use of match and time motion analysis. Validity and reliability of the use device were thoroughly assessed with the preliminary study. This measurement quality assessment study showed that the semi-automatic match analysis system used was valid, reliable, and accurate. Unfortunately, the data previously reported in other water polo studies did not report the accuracy of the used match analysis system, and consequently the comparison between this and other studies results in doubtful. As a consequence, the working hypothesis, existence of higher game demands after rule changes, can only be partially supported by examining distance coverage. The mean blood lactate concentrations achieved by players of this study was 7.7 plus or minus 1.0 millimoles per liter, range 2.2 through 14.3, a value that was quite higher than those reported by Platino and Galatas and Rudick et al. i.e. 4.03 plus or minus 0.96 and 6.40 plus or minus 2.23 millimoles respectively. For experimental and training-friendly matches respectively, however, this study's mean 7.7 plus or minus 1.0 versus 8.55 plus or minus 2.56 millimoles, and peak 14.3 versus 11.58 millimoles blood lactate concentrations were similar to those reported by Rodriguez, studying elite-level Spanish water polo players. Differently from Platinow and Galatas, the Rudick et al. Study, Rodriguez examined match demands during a playoff final. Consequently, the mean and peak blood lactate concentrations reported by Rodriguez supported the assumption that a competitive level effect on match demands in water polo. This warrants the ecological validity of this study design. With the study's findings, the high-intensity nature of competitive water polo previously reported was confirmed. Analysis of playing role activities showed that game demands were slightly higher for center forwards and center defenders than the other players. Center defenders swam 8.4 and 37.9% more distance than did field and center forward players respectively. P is less than 0.05. Although the central defender's coverage rate resulted in being comparatively significantly higher than the other playing roles, this was not reflected by blood lactate concentration values. Indeed, central defenders and field players reported blood lactate levels that were 40 and 53% lower than center forwards, respectively. Probably differences in game demands were because of the tactical peculiarity of playing roles, because usually center forwards are underrepresented in team rosters and are usually involved in long wrestling activities with defenders during the game. These later activities involving continuous shifting from horizontal to vertical posture coupled with isometric contractions are reported to be the most demanding among the various water polo activities. This probably accounted for the superior blood lactate values reported in center forwards despite their comparatively lower field displacement. Interestingly, in an unpublished sub-study, we found that for tactical purposes, field players acted as center forwards, 10, the resulting blood lactate concentrations were significantly higher, and as those achieved by pure center forward players, P is greater than 0.05. This strongly suggests that game demands are role dependent and mainly linked to the individual skills required for it and to tactical requirements. This finding is in contrast with those reported by Hallman and Frace and Smith that found that skill and physical fitness but not game demand differences among playing roles in elite male water polo players, because the cited research studies were carried out before FINA, FINA rule changes, i.e. before 2006. It could be speculated that this study finding may be natural consequences of them. Again, differences in data collection methods and research design make definitive inferences difficult to be drawn. Although water polo rule allow unlimited players substitutions during the game, a significant decrement in coverage rate was observed across game quarters, table 2. Indeed, despite no significant variation in total distances swum and blood lactate concentration values during game quarters, a significant decrement in coverage rate considered as distance covered per minute was found during the last part of the competition. Although for reasons for such coverage rate decrement are difficult to be explained, with this research design variation in swimming speed may be partly account for the significant decrease in high intense activity during the last stage of the game. Indeed, during the last quarter, players experienced a significant decrement in percentage of distance covered at a speed higher than 1.8 meters a second. This result confirms the findings previously reported by Platinow and Galatas that shows a significant effect of quarter duration, 7 versus 9 minutes per quarter, over overall match coverage rate. As a consequence, the coverage rate decrement reported in this study may be considered as a direct consequence of variation of FINA, FINA, rules in quarter time length. Other match activities such as defensive and attacking jumps, tackles, hands up, marking, swimming style changes, forward crawl to backstroke, and sculling, together with postural changes from horizontal to vertical, may exert physical demands that could generate perturbation on players' coverage rates. In this study, we observed as much as 4.6 plus or minus 0.6 shift from the horizontal, supine or prone, float to vertical posture per minute. This means that during the entire match, players may perform up to 120 postural changes that may put strain on large body muscles. This is of particular interest because match analysis showed that players spent 21%, 355 plus or minus 169 seconds, pardon me, and 28.3%, 480 plus or minus 210 seconds of match time in active, offense, and defense respectively. Swimming accounted for the remaining 51%, 874 plus or minus 351 seconds of playing time. In this study, no physical fitness assessment was performed on the players studied. Consequently, it was not possible to track fitness-related variation in match performance as previously reported in soccer and basketball studies. A recent study suggests that an effect of intermittent high-intensity endurance over match performance may be expected in water polo players. However, in the cited study, Mujica et al. Did not provide systematic information about the relationship between players' fitness and match coverage rate because only a qualitative analysis was carried out. Consequently, future studies coupling sound match analysis and match physiological measures with field and laboratory fitness assessments are warranted. As a working hypothesis, we assume the existence of an increase in game demands as a consequence of FINA's new rules. This assumption informed the procedures of this research design and results of which partially supported the hypothesis considered. Blood lactate concentrations and distances covered showed that current international level water polo competitions impose important physical demands. Furthermore, remarkable role-dependent game demands seem to be experienced during highly competitive matches by male players. These findings foster the previously reported evidence-based view that proposed men's water polo as an intermittent high-intensity exercise mode. Practical applications. The blood lactate values achieved by elite-level water polo's players of the study resulted in being higher than those previously reported by other authorities that addressed this team sport before 2006, i.e. before FINA rule changes. This may suggest that current water polo demands are more anaerobic in nature than were previously recommended. As a result, water polo physical conditioning training should consider anaerobic high-intensity training to develop players' game preparedness. Role-specific conditioning is strongly suggested because important differences in coverage rate and anaerobic pathway involvement were found among playing roles in elite-level water polo players. In this regard, center defenders players should be involved in intermittent high-intensity endurance training, whereas center forwards ought to consider anaerobic training.